Good morning to everyone. Myself K. Lakshman. My team members of Mukeshwaran and Vishnu Prakash. I'm going to hear my final year project automated CCTV anomaly detection in crime mapping and analyzing system using deep learning. And my under guidance supervisor of Mr. Murugan G, assistant professor of CSPS. Abstract. Our project is AI based surveillance system that detects suspicious activities and identifies suspicious in criminal in real time. We using for the deep learning techniques like object detection, post estimation, and face recognition. The system can detect weapons, aggressive behavior, and unknown activities. It is also send the real-time alerts authorities reducing monitoring. For example, railway station, if you have a person in carrying a weapon or behaving aggressively, our system can automatically detect the alert security immediately by enhancing situational awareness and enabling proactive threat identification. Okay, then introduction. Nowadays, crime increasing and traditional CCTV systems are not enough. Okay, they only record video and require human monitoring due to human errors like failed to many incidents are missed. So we use AI deep learning to automatically analyze video and detect threats in real time. And then problem of the statement. Current system depends on manual monitoring, which is insufficient. They cannot detect threats automatically. Face recognition is not accurate, poor lighting or different angle. Also, there is no system that combines object detection and then objectives. Our main objectives are detect the suspicious activities, automatically identify the weapon using YOLO algorithm, analyze human behavior, recognize the criminal faces, send your real-time alerts to authorities. For example, if someone is holding a knife or gun, YOLO detects the object and draws bounding box around it labels to weapon. Okay, and then literature service. We study the previous research on crime detection using deep learning. Some systems focus only on object detection or violence detection, but they lack of integration and real-time alert system. Our system combines all these features into one. Okay, we are collecting for the design real-time crime monitoring system, and then neural structured learning using system focus only on object detection or violence detection, but they lack of integration and real-time alert system. Our system combines all the features into one. Neural structured learning using vision transform for violence detection and review deep learning based detection of the violence video, image and video based crime prediction, YOLO object detection deep learning. These are for them. Existing system. The current surveillance system mainly rely on CCTV cameras, but that only record video footage. The performance that depends on human monitoring, which is lead to miss the incident cannot be detect weapons suspicious behavior automatically respond time, which is very slow. Existing is proposed. The proposed system the employee analyze detect weapons using all algorithms and the behavior using the estimation recognize the criminal faces using CNN. Finally, it send the alert instantly to improve safety. Proposed system is existing system. In existing system, the theft happens. We check the video only after incident. Proposed system, but this one our system it detects the suspicious activity before or during the incident and alert immediately. Overall architecture. The diagram shows the overall working of the system. The camera captures the video, then it goes through object detection, face recognition, and behavior analysis. Finally, alert are generated if any suspicious activities detected. First one, the real-time environment and enable the camera for capture the faces, capture the screen. Final face detection, foreground detection, and then suspicious activity criminal face datasets. Okay, using for the YOLO algorithm, activity analysis, grid selection, weapons, suspicious activities, alarm, criminal faces, the speaker, message alert, alarm, the violence classification. Then tools and description, hardware requirements, software requirements. We used Python as the programming language, the TensorFlow, Keras for deep learning, PyCharm as ID. This system run basic hardware system with Windows OS. Hardware requirements: the processor, Intel processor, RAM 1 GB, hard disk 160 GB, compact disk, keyboard, standard keyboard, monitor, 50-inch color monitor. Okay, then software requirement: operating system, Windows OS, front end Python, IDE, PyCharm libraries, TensorFlow, Keras. Algorithm and method description. YOLO based algorithm detection. We use the YOLO algorithm object detection. It object like weapons in real time. For face recognition, we can use the convolutional neural network based model Grassman technique. And then Grassman based recognition system. The Grassman technique compares the faces with criminal database and identify matches. Detect the faces from the captured video frames using deep learning detector, extract facial feature, a convolutional neural network. Map to extract the facial feature. Compare the Grassman suspects detect to faces which store the criminal face suspect the detects. Computer similarly score the to identify matches. Generates the recognition, the result of triggered then. A list of the models of systems like the camera input, face recognition, object detection, activity analysis, and analyzing system, YOLO based object detection, foreground detection, and security analysis, criminal detection, alarm and notification. For example, if a weapon is detected in a mall, that system will instantly send the alert message to the police or security team. Model description. Each capture camera activation and skin capturing. Initially, the surveillance camera establishment the live video feed continuously capture the real-time footage from monitor area. Transform capture the video frame the processing unit. Face and detection and recognition. To detect the human faces, each video from using the deep learning method uses the convolutional neural network based on the future extraction, the robust facial representation. Each model performs a specific function. The camera captures the video, face model detects the faces, YOLO objects, activity analysis detects behavior, and finally alert model send the warnings. And then YOLO based object it identifies the objects such as the weapons and suspicious item in the scene. Use the YOLO you look only once. The model for the fast accurate the object location. They classify the detection object into the threat related categories. Some of the providing bounding box the coordinates for alert further analysis. The another fourth one the foreground detection activity analysis separates the moving object. YOLO detects object activity analysis detects behavior, and finally alert model send the warnings. The violence and threat classification identify the aggressive or violent behavior patterns. They combine the motion and object detection result the threat assessment. The sixth one is criminal face detection database management. Matches the detected using the Grassman based the someone previous based future comparison for accuracy. Update the managing criminal face database. Some the stored recognition some databases stored to using for the recognition criminal faces. Last one for the alarm and emergency model. The trigger the alarm when you enter the theft person in the faces already is stored for the database. Some suddenly identified to alert the police and then security system team. The log alert the event for the future investigation. Last one for the reference. We refer to research paper related to deep learning crime detection and surveillance system. This one collecting for the papers, the research and using.